Hey guys, in this lecture video, I'm gonna discuss about the basics of the MSE wall. MSE wall is the mechanically stabilized earth wall. So this is MSE wall, which is known as mechanically stabilized earth wall. Now, in the MSE wall system, there are like different things that we need to learn, and we are gonna discuss mostly the basic steps here. So first of all, what is how the MSE wall works and what is it? So the MSE wall is a very similar system like the gravity wall or the concrete retaining wall that we discussed. So far, what we have learned that in our concrete retaining wall, um, we have a wall system, and it's gonna retain some soil on the back. And the way it's gonna retain is the wall will have some weight on top of it. So it'll have the concrete, and at the same time, it'll have some kind of soil in it. So as a whole, the whole system is gonna create a gravitational soil block or gravitational block, which is gonna push or which is gonna keep to the soil in place. So the gravitational wall system is gonna create a massive wall, massive weight that's gonna hold the soil in place. The MSE wall is very similar to the same system. This is nothing but the gravity wall system. So what happens in the MSE wall? Instead of just using the wall, the concrete wall, we have to use something else. So instead of using this wall, we have to use something else. So what happens in the MSE wall system? It's kind of creating a stabilized soil blocks. So this is a stabilized soil blocks, and it has different components. We are going to discuss each of the component a little bit later. But what happens in the MSE wall is it just create a big chunk of soil, and that soil has its own weight, and due to this weight is gonna retain the soil on the back. So what the MSE wall will do here is MSE wall is gonna create a wall system or a certain weight, and it's gonna retain all the soil on the back of the wall. So the first one is the concrete retaining wall. Great retaining wall, and the second one is the MSE wall, and both of the system is known as the gravity wall. Okay, now let's think about, okay, now let's discuss what are the components of the MSE wall and how it works. So first of all, let's discuss regarding the angle of repose. So let me draw a line. Let's consider this is our ground line. So we have our soil, and then we are trying to pour some sand on top of it. When we are putting some soil or sand on top of it, it's going to create an angle with our ground. So let's say this angle is theta, and this angle is known as the angle of repose. Angle of repose. Okay. So the angle of repose is the soil itself is stable, but it just creates a certain angle depending on whatever the uh, the frictional capacity in between the soil blocks. So basically what happens, this angle of repose is nothing but the phi or the friction angle of a sand. Okay, now let me ask you a simple question here. What if we try to put some load on top of it? Okay, so we kind of like we put in some load on top of it, and we gonna remove this, the top part, because we're pushing it. So what's gonna happen? What do you think? This load is gonna push the soil, right? And due to this push, maybe the side is gonna move. This side is gonna move, and then the other side gonna move, the other side gonna move. And after a certain push, maybe this will settle down something like this. You know, this will settle down something like this so that it can take that load. You know, it will settle down with the load, and then the angle of repose will change because it'll get stabilized with a different angle. It has to come to an equilibrium conditions. But if there is a way that we can add something in between the soil that might create some internal friction or enhance some internal friction within the soil, so that enhancement of the internal friction will try to keep the soil in place when we are trying to add some load on top of it. For example, the way the soil is now, if we add few layers of reinforcement inside the soil, few reinforcement inside the soil, what happens, we are putting some load on top of it, and with this load is gonna create a bulb, a pressure bulb. And within this pressure valve, this is gonna push the soil, this is gonna push the soil. But when it is gonna push the soil will have some interaction between the reinforcement inside. There will be some interaction between the reinforcement inside, and that reinforcement will try to keep the soil in place, which is the adhesion and the friction, right? So, and with this, it's going to enhance the shear force or the shear resistance. So it's going to enhance the shear resistance, and with the enhancement in the shear resistance, the soil can take more load. And gradually, if we can place it right, what's gonna happen is the soil can maybe able to stand at a higher angle of repose. The soil may itself stand here with a higher angle of repose. Not necessarily it has to be with with a very shallow angle or a flattened angle, but it might be much steeper angle if we can just add some rebar in it. You know, that's one thing. Now the second thing is, uh, if there is a way, we also can add some kind of facing on top of it, some kind of facing on top of it, which kind of holding the soil in place. We maybe will be allowed to make a vertical wall just by adding some facing on it with some kind of reinforcement. That's something I'm going to discuss more. But what is happening here, let's say we have the soil. Within the soil, let's say whatever the soil is, no facing, just the soil, but we are keep adding some reinforcement inside the soil. So that reinforcement, which can be something called geogrid or geosynthetic or geotextile, or even some kind of steel rebar, strip rebar. Okay, if we can add something which is gonna add some frictional force between the soil body, which is going to enhance the shear capacity of the soil, will uh, will act will let the soil sitting at a higher angle, you know. And when it's gonna let the soil sitting at a higher angle, uh, this kind of block or this kind of system is kind of like the soil is mechanically stabilized, because we are stabilizing the soil with some reinforcement element within the soil, and adding that reinforcement element is kind of enhancing the shear capacity of the soil. So the whole system in this way is known as the mechanically stabilized earth system, or the MSE. So it's known as the MSE system is something that uh, we need to add within the soil body, like some kind of reinforcement, and which is going to keep the soil in place. So using this technology or using this technique, we can make some big massive walls, so which works like a gravity wall system. So and that gravity wall system has to be designed for two different things. One is for the external stability and the other one is the internal stability. So the external stability that we have discussed so far, we have to check it for three things. One is the overturning, sliding, and bearing capacity. The internal uh, resistance or the internal stability is determined based on the pull-out capacity of the reinforcement and as well as the tensile capacity of the reinforcement. So we need to check for several things, and this is what we're gonna discuss in this lecture.